Good morning, students. I welcome you all for the another interesting session. So today we're going to take one more problem and try to find out the support reactions. So the problem is like this: find the reactions at A and B for the beam shown in figure. So there are two supports at A, that is, and another at B. So this is hinged support and this is a roller support. So AB is a beam. It is subjected to point load, then a moment, then this is UDL, and here one more point load is there, and again in this portion there is a load. Can you identify which load it is? So we have seen already point load, we have seen UDL, we have seen a triangular load. Now another load it is, right? So this load is known as a trapezoidal load. This comes under uniformly varying load. So in uniformly varying load there are two types. One is triangular load, okay, and another one will be trapezoidal load. So this is a trapezoidal load. Then how to convert this trapezoidal load into point load, we're going to see that. Okay, first we're going to draw the free body diagram. So again this is a point A and this is point B, or support A and support B. So since it is hinged support, there will be two reactions, RAH and RAV, and this is a roller support, only one reaction, that is RB. Okay, so RAH, RAV, two reactions at hinged support, and RB, one reaction at roller support. Okay, this is regarding reactions. Now point load, as usual we're going to show, that is 2 kilonewton, and this moment 4 kilonewton meter as it is. Now first we're going to convert this UDL. Okay, so how to convert UDL into point load? So see the intensity. This is 5 kilonewton per meter acting for length of how much? 4 meters. So from here to here it is UDL. So 5 into 4. 5 into 4 is 20 kilonewton. This is a 20 kilonewton point load, that is converted UDL into point load. And where this point load is acting? 20 kilonewton, half of this 4 meter means 2 meter from here, 2 meter from here. So this 20 kilonewton will be 2 meter from this end and 2 meter from support B. So this is converted UDL into point load. So 5 into 4. Okay, next. So at the same point 10 kilonewton point load will be there. So we're going to show one more load here, 10 kilonewton. Okay, so this is conversion of UDL into point load, and this is point load as it is. Now come to this point. Okay, as we know, this will be the trapezoidal load, and again trapezoidal load will be converted into point load. Okay, just see this portion now. Okay, this is the part where we are going to convert this trapezoidal load into point loads. Now again you can see here what is the maximum intensity? Here it is 1 kilonewton. Okay, then here the intensity is 3 kilonewton per meter. Here it is 1 and here it is 3. Okay, now this trapezoidal load will be considered into two parts. One is UDL. Now see this rectangle, this is 1. Okay, and if you consider only this one, so from here to here it is again 1. So this complete rectangle, what you can see, this will be considered as UDL. Here it is 1, 1, 1, 1. From this to this it is 1 kilonewton. Means I have drawn here dotted line. Okay, so below this dotted line this will be UDL, and this, can you see this? This is a triangular load now. Okay, this is a triangular. So total trapezoidal load is converted into, okay, total trapezoidal load is converted into what? UDL and one triangular load. So see this, how to convert trapezoidal load into point load. So first is UDL. So this is 1 kilonewton. Okay, here it is 1. Here also you have to take 1. Okay, 1 kilonewton. So this is the UDL now. So it is acting for a length of how much? 3 meter. Okay, 3 meter UDL. Now convert this UDL into point load now. Now this is a UDL. As you know how to convert UDL into point load, take a intensity. This is 1. It is acting for length of how much? It is 3 meter. So 1 into 3, that is 3 kilonewton point load now. So what we have seen here, 1 into 3, this will be 3 kilonewton, converting this UDL converting this UDL, that is 3 kilonewton. And where this 3 kilonewton acting? Half of this 3 meter. Okay, half of 3 meter means from here it is 1.5 here, from here 1.5, and from here B. Okay, from B it is again 1.5 meter. So this is 3 kilonewton point load converting this UDL. Now what is remaining now? This UDL is gone now. Now consider this triangle now. Can you see this triangle now? Triangular load. See here, I have drawn here triangle. Okay. Now triangle here. So this 1 is already gone. What is remaining here now? Intensity 0. Okay. Here it is 0. Here the load is 0. And what is here now? This is how much? Total was 3. Okay. Total load intensity was 3. Out of 3 already you have taken this much. Okay. This is 1 we have taken. What is remaining now? 2. So this will be 2. Okay. This will be 2. Now this is a triangular load. Okay. One end is 0 intensity and this end it is maximum 2 kilonewton per meter. So this is a triangular load. How to convert triangular load into point load? Take the area of this triangle. Take the area of triangle. What is the area of triangle? Half base. So base is 3 meter now. Half the base and height is this 2, not 3. Out of 3 we have taken already here 1. Okay. What is this remaining? It is 2. So half base is 3 and height is 2 kilo. So totally it is 3 kilonewton. So point load is 3 kilonewtons here. This point load, triangular load converted into point load is 3 kilonewton. Then where this 3 kilonewton is acting now? Okay, it is not a UDL. UDL it is, if it is UDL it is half, but it is triangular load. So for triangular load when you convert into point load, the point load will be acting. Okay, now see, can you see this is 0 intensity, means this is 0 intensity. From 0 intensity, okay, the point load will be 2/3 of base. Okay, now see here, point load will be, this point load will be 2/3 of base. This is 0 intensity. From this it is 2/3 of base. So that is 2/3 times of base. What is the base now? This total base is 3 meter. So 2/3 into 3, okay, means 2 meter. So 2 meter from this 0 intensity, means here it is 0 intensity. From this 2 meter, now see here, this is 2 meter, not this. Okay, this is already you have converted in this UDL. Now you are considering triangle. So from this 0 intensity it is 2 meters here. From this it is 2 meter and remaining is how much? From this it is 1/3. Okay, from this it is 1/3 of base. So 1/3 of base is 3. So 1/3 of 3 is 1 meter. So this triangular load we have converted. We have taken the area of triangle. Then it is a point load. That point load will be from 0 intensity it is 2/3 of base, and from maximum intensity it is 1/3 of base. So means from here it is 2 meter and from here it is 1 meter. And this 3 kilonewton is converted this UDL. So at this point, this portion 3 kilonewton, that is 1.5 and 1.5. Then this 3 kilonewton point load, from here it is 2 meter and from here it is 1 meter. So this is what the free body diagram, what you can see. So this is important, how to convert triangle, that is trapezoidal load into point load. So if it is a trapezoidal load is there, you can divide that into two. One is UDL, another will be triangle. So this is what we have converted. So once the free body diagram is drawn, next use the equations. So let us use summation Fx equal to 0. Okay, all the horizontal forces is equal to 0. So how many horizontal forces? 1, okay, 1, 2 and 3. So there are 3 horizontal forces. So this is plus. So plus RAH, this is minus 3 and this is minus 3. So plus RAH, minus 3, this is summation Fx, this is equal to 0. Okay, so therefore RAH is equal to 6 kilonewton. RAH is equal to 6 kilonewton. Now next, this is one equation. We have got reaction RAH is equal to plus 6, means this direction is correct. Next we will going to take one more equations of equilibrium, that is taking moment about A. Taking moment of all these forces about A, about this point A. Okay. So therefore the moment of RAV will be 0 because these two are passing through A only. There is no moment. Now remaining is how much? Moment 1, 2, this 2, 3, 4, 5, 6, 7. Okay. So for these moments we are going to take, that is force into perpendicular distance between A and these forces. So take one by one force, that is summation MA is equal to 0. Here this point is A. So note down, I have not written here. So this point is A, this point is B. Okay. So taking moment of all these forces about A and summation MA is equal to 0. First this force, because these two will be 0, we'll start with this. So 2 kilonewton, what is the perpendicular distance between 2 and A? That is 2 meter. With reference to A, this will going to produce clockwise. This will produce clockwise. So plus 2 into 2. Plus 2 into 2. Next this. So this is already moment. Okay. Don't multiply perpendicular distance. Just you have to see clockwise or anti-clockwise. This is clockwise means plus 4. Plus 4. Okay. Next this 20 kilonewton. What is the moment of this 20 with reference to A now? This is a force 20 into perpendicular distance between this force and A is 2 plus 2, 4 plus 2, 6. And with reference to A, this 20 will going to produce clockwise. So plus 20 into 6. Next, this 10 kilonewton. So again 10 into same distance is 6. Again this will be plus. So plus 10 into 6. Next this RB. Now see, with reference to A, this will going to produce anti-clockwise. This will going to produce anti-clockwise means minus. So minus RB into 8. What is the perpendicular distance between this RB and A? That is 8 meter. So minus RB into 8. Next this 3. Okay. Now this is the point A and this is the force. With reference to A, this will going to produce, okay, anti-clockwise. Okay, this 3 kilonewton is going to produce anti-clockwise. So it is minus 3 into 1. So this is 3 force and this perpendicular distance between A and this force. If you extend this force here, okay, the perpendicular distance between this force and A is 1 meter here. So minus 3 into this, minus 3 into 1. Next similarly last force, again this is 3. Again this will going to produce anti-clockwise. Okay, anti-clockwise means minus 3 into perpendicular distance between this force and A. So this distance, if you extend this force here, okay, the perpendicular distance between this and A is, this is, okay, 1.5. This is 1.5. See, the perpendicular distance between this and A is 1.5 and the perpendicular distance between this 3 and A is 1. We have taken minus 3 into 1 and minus 3 into 1.5. This is summation MA. This is equal to 0. Okay. So we have used another equation, that is summation MA is equal to 0. So from this equation we can get RB is equal to 22.56 kilonewton. Plus we have got means the correct direction, what we have assumed is right. Okay. Now another equation is left, that is summation Fy is equal to 0. That is summation of all the vertical forces is equal to 0. So how many vertical forces? Count 1, 2, 3, 4, 5. So these are horizontal forces. Don't consider this. Okay. 1, 2, 3, 4, 5. So now see, this is plus RAV upward, plus RAV, minus 2, minus 20, minus 10, plus RB. Okay. See, plus RAV, minus 2, minus 10, minus 20, plus RB. This is equal to summation Fy is equal to 0. RB value you can substitute here and get RAV that is 9.44 kilonewton. This is also plus, means this is the vertical direction. What you have assumed is correct. So final readings you can write down. RAH we have calculated 6 kilonewton. This is the direction. RAV, this RAV 9.44 kilonewton. It is upward. And reaction RB at B, this is 22.56 kilonewton. This is upward. So these are the final reactions. At A, hinged support means two reactions, RAH, RAV. And at B, roller support means one reaction, 22.56 kilonewton. So this is what the problem we have considered today, and this is important. Okay, so when trapezoidal load is there, how to convert trapezoidal load into point load? So divide that trapezoidal load into two parts. One is UDL and another will be triangular load. So this is UDL, that is 1 into 3, and then this triangle, this is a small triangle, what you can see here, I drawn here. Here it is 0, here it is, out of 3, 1 you have taken here, remaining is 2. So this is 0 here, and here it is 2. So once again you can solve this problem. If you have any doubt, okay, you can ask me, and we'll come up with another interesting problems in the next session. So I thank everybody for attending this session. Thank you very much.